Hi everyone, I'm Yihao. With Ryan, Liuming, and Kanli, we're gonna show our design, which aim to prevent account takeover, which is ATO, protect the security of funds and sensitive data within the financial system from misuse. I'm showing the identity and access governance part in our design. We choose implement identity and access governance through a multi-layered protection approach. First is strong authentications. All employers log in via SSO with MFA enabled. This will significantly reduce the account compromise risk through the MFA. Second is the least privilege principle. Each account is granted only the minimal privilege required for the task execution. With the unused roles, we regularly just reviewed and revoked. Third is long-term credential protocols. Policy protocols the credential of long-term access key. Everyone knows that we shouldn't have a long-term access key, but people will be lazy. So ban this one will significantly reduce the risk. The final one is auditing and traceability. All the operations are logged and monitored via cloud trails and access analyzer. Enable traceability and fast response. Yep. Okay, this is my AWS. You can check. And what we do now? Let's show you my cloud trial. Okay, you can see. I created a cloud trial called ATO trial, and this is event history when I create the trial, and then the trial record what I did. This is a work I will do before. And what's next? For test the trial, and we need to get to the IAM part. Okay, you can see I set two users. One is with MFA, another is without. Two users in one group, test user group, and in this group, actually I gave it 4 policies. This just reading access the reading source policies. The user with MFA can read the S3 resource, and this is deny access keys. I just banded normal user. They cannot create access keys. Also, this one deny without MFA. If the user do not have MFA, they cannot access to the resource. This one is require MFA for credential operations. This one is even the root user. If the root user don't have the MFA, they cannot do some operations very very important, such as create access key or something. Yeah, so let's check the user. The first one we show the user without the MFA. Okay, let's see. Wait a minute. Okay, you can see we got a lot of access denied over there. And let's go to the S3 bucket. Let's go to the bucket. Okay. Create bucket. Let's go to the bucket. You can see I cannot access the bucket. Okay, let's go sign out. Let's try the user with the MFA. You see, this user requires MFA, so my Google Chrome just shows, do you want you to make sure go through with the MFA? And you actually have three ways to choose MFA. One is using Google Chrome, another two is using your phone or access key. Okay, you see, we still get the access because I give the least privilege. Let's go to the S3 bucket. Okay, let's see. You see, the user with MFA can read the bucket. And let's go inside. Yeah, you see, we can read. Okay, what's next? Okay, let's get out to the row user. Yeah. Also, in these two users, you cannot create an access key, but or row user can. You can see over there. You see, we can create access key, but in these two users, whatever you have MFA or not, you cannot see this button because the AWS they ban for them because I didn't give their permissions. Okay, what's next? Next is access analyzer. I enable the access analyzer in my AWS. But you can see we don't have any findings over there because I didn't change the bucket policy. So if you got any resource, outside resource, you don't allow them or you don't want them, this analyzer will help you to find out and check. Then you can block them. Also, like some very tricky bucket policy, they will also give the permission for outside the third user, and you also will find by this one. So what's next? Next is the rows. Okay, so what I can see, okay, rows over there. You can see this one is if some rows, some users they stop use like for a long time, and then you can check over there. You can see this one, last activities 2 hours and 11 minutes ago. If in organizations a user they last activity for 30 days long, then you can choose them and choose delete them or delete their permission. But I think delete the whole row is a better one. Okay, so that's it. Thank you.
Hi, my name is Riven. So I build a secure, editable, and less privileged cloud-based API system. successfully implement the SDLC with the AWS environment. The project embedded financial grade security requirement directly into the cloud architecture. Hi, my name is Yuan. So now I'm showing the setting up of the boundary and API protection. So first we need to make a minimum API. So first we need to go to Lambda and create a function. So I already created a function which called cloud remote. So here it's showing we already successful connecting. And now we are going to the API gateway. So now you got two cloud free, two API, which one is cloud free and cloud free REST. The cloud free is my first version, which is a HTTP API, but it can't do the flow control. But so we can only use REST API. The REST API can do the flow control. And now after we creating the API, we go inside. No, we go into the usage plan. And we create a flow control. In this case, it can only 1,000 access per day. So you can change any way you like. And now after we create that, we go to the go to inside the API, and we can see a link in here. And we go to the link. It will show missing, which not what we want to show. So if we want to correctly access the link, we need to add a slash test, which is showing the forbidden. Now we already create our minimum API. So we want to make our API more safe. So we need to get an API key. So we need to open our API, choose our API, and go to resource and get. And now we can see the API key required. So it should be closed in the beginning. So we need to open it. And after you open it, our access we need API key. So if our adding test it doesn't work, it's showing forbidden. So how can we success? We need to go into API key and find our API key and show and copy it. And we need to copy the API key and the link, copy it and paste to our CMD. Then we can access successfully. Yeah, it's showing successful. And when the verification is complete, it said that if the maximum traffic is set, it will showing 429. Now we are only doing the API save API access, so we still need to save the log. So we need to open the API gateway and get and go to the stage, and we need to open the CloudWatch log, which record error and info log. But in the beginning, the account we can't open this, so we need to give the permission. We need to go to IAM and roles. We need to add a API gateway CloudWatch log role to give this role. And now we go back to the CloudWatch to check if I'll open it or not. Yeah, will they open it? So we need to go to the CloudWatch, the log group, to find the log we create, connect to the API. And we pass it in, and it will show the log stream. This area should be showing empty at the beginning. So all the access, even with API key or not, they all will be recorded. So finally, we need to setting up our minimum privilege setting. So we need to go to open the IAM and go to roles and find our API, and we need to give the policy. We need to look at policy. And we need to setting up the AWS Lambda-based execution role and Amazon API gateway invoke full access to prove I have the minimum privilege.
Hi everyone, my name is Yumeng Like. My project focuses on data protection and backup resilience. This diagram shows how I use AWS service to protect data. The process starts with the EMS encryption, then RDS, and then the S3 stores all the encrypted data. The data is backed up automatically in AWS Backup Vault and the CloudTrail. It tracks every actions, and altogether these services make sure all the data is secure, auditable, and easy to recover. The first step is to encryption using the AWS key management service. So I create a key and enable automatic key rotation. So a new version will generate every year. This key encrypts everything that's stored in RDS and S3 and AWS backup. And it protects data when stored and when transferred, forming the foundation of my system security. Then we have the Amazon Aurora RDS database. This database stores the main financial data, and it encrypts with my encryption key and run in multiple availability zones for better reliability. I also enable point-in-time recovery, which can keep 7 days of the backup. This means the database can be restored to any time within the period if anything goes wrong. Then this slide shows how the database is set up, and It is a private network, encrypt and connect to AWS backup for automatic snapshots. This setting keeps the data protected and ensure the database is always available and recoverable. And for long-term storage, I create a S3 bucket, and I turn on the object lock and the versioning, so the file cannot be deleted or changed. And I also enable SSE S3 encryption. It protects every file automatically. This one creates a secure and read-only archive for storing logs and old records. And the next one, I set up a backup valve, and it used the valve lock to stop anyone from deleting backups early. So the valve stores encrypted copies of all data and provide a long-term protection against any loss or tampering. So to automate the process, I made a daily backup plan to connect my valve. So it runs every day and moves all backups to cold storage after 30 days and delete them after 1 year. This makes the backup and recovery automatic and reliable. And finally, the AWS Cloud Trail keeps track of all activities in this account. It records events like creating keys and running backups and restoring data. And logs are encrypted and verified, so they cannot be changed. And CloudTrail provides evidence for auditing, so it helps to meet compliance standards like the Privacy Act. And in summary, I use KWS, RDS S3, and AWS Backup and CloudTrail to create a secure, automated, and auditable system. So altogether, they protect sensitive information and make recovery quick and reliable. That's all for my presentation. Thanks for watching.
Hi everyone, my name is Chin Kang Lee, and today I will be presenting the monitoring and emergency response part of our AWS architecture. This setup focusing on how our system detects, frees, and notify when a potential security threat occur. First, CloudTrail. It's continuously monitor and then log all the user and API activity in our AWS environments. Then GuardDuty automatically scan those logs to detect any suspicious or malicious behavior. When a threat is found, CloudWatch events or even breach trigger an alert. That alert is sent through SNS, which forwards a notification email to the security team. At the same time, a Lambda function is automatically executed to respond to the incidents, for example, isolating or freezing the effects instant to stop the threat from spreading. This whole process makes sure our system proactive, automatic, and efficient in handling security emergency. Now I'm gonna show a short demo to explain how this process actually works in actions.
First, we go to console and then we search for CloudTrail and fill out this console. I chose management events. Click on create trial. Next, let's enable GuardDuty and type GuardDuty and then click enable, and that's it. Now we create an SNS topics for an alert. We click next and then create topics and choose standard. For names, I choose GuardDuty threats alert and create topics. The topic is created, and then you need to create the subscriptions. For protocol, choose emails, and for endpoints, just fill out your email address, and you will receive an an email from AWS. Click on the link for verifications. Next, we're gonna go to AIM and click roles and create. Select AWS servers for trust entity types. Click next, and then search basic executions role and click on it, and I'm gonna name the roles and then click create. After that, head to Lambda, create, and here choose Python 3.13 and architecture, choose 64 bits. Select the IAM roles, and then we just create it and create functions. Now the Lambda function is created, so I'm gonna just copy this code and paste it, and then click on deploy. Then we're gonna configure the environment. So go to environment, variable, and click edit. The key we just gonna fill out, and then for the ARNs we just need to copy from SNS ID and paste it, and then click save. Then we go to the permission policy and add permissions, then create the inside policy, and here for the JSON code we're just gonna paste this code and simply replace your region's account ID and topic names. Next we go to Amazon Event Bridge, click roles, and then create roles, and then we fill out, and for the event bus just leave it default. Then we click next, and then select AWS event for an event source, and then for the event type select guard duty finding and click next. After that we click guard duty automatic response for the targets and click next. Okay, now let's review everything here. We have rule names, event pattern, and we have target here, and just click create role. Now go to guard duty console, copy this ID, and then just type into the command prompt, and later on you will receive an alert in your inbox. That's it. Thank you.